My name is Diane Nembhard, and today's date is the 21st of the 7th, 2023, and the time of the course is 9:30. The course that's getting delivered today is fiber optic, and it's being delivered over Teams. The duration of the course should be 15 minutes. The aims of the session is to equip learners with the knowledge of optic fiber, to check learners' previous knowledge and experience on fiber optic, and to understand how fiber optic works. By the end of the lesson, learners will 1. Identify what fiber optic cable is, 2. Understand how fiber optic works, and 3. Explain how it is used. So, welcome to your fiber optic course, cable course. So, as you probably all know, that we are heading for a digital world. By 2025, the analog network will be switched off, and this means that the network will all be digital. As you can see from the diagram, the old copper network, which is the old copper network through the PCP box. But now everything's been uploaded to the fiber digital network. You have the telephone exchange direct from the telephone exchange straight into your house. Anyone who has not moved to a full fiber internet-based telephone service will not be able to make calls or use service which rely on analog transmission. The big switch off will change how services are delivered. Ultra-fast full fiber network connects homes and business across the UK direct to the exchange with a single pure fiber cable. It will give you speed up to 10 times faster than current technology has. 70 to 80% fewer faults than the current technology that relies on a mixture of fiber cables and copper cable, leaving you with no more buffing or downtime and future-proof the nation for decades to come. So, fiber benefit. With full fiber broadband, you'll also get cutting-edge voice technology. That will mean that rather than your phone calls using the traditional telephone network, they'll use the broadband network, just like services such as Skype, Microsoft Teams, and FaceTime. With full fiber, you'll be able to stream 8K TV or Ultra HD on multi devices all at the same time without buffering or interruptions. Working from home will be a breeze, enabling 1 million people to return to work and help the environment by saving 300 million commuting trips. So, to start, I'd like you to go into your groups and share any knowledge or experience about fiber optic, and then we'll bring it into the class and we'll share all together. So, what is fiber optic cable? So, when we speak into a landline telephone, a wire cable carries the sound from your voice into a socket in the wall, where another cable takes it to the local telephone exchange. So what happens is, in the exchange, that is where your server provider equipment is, and it's connected to a pair of wires. The pair of wires leave the exchange, go underground, and goes through all different connection points, so it reaches to the PCP, which is the primary connection point. This is the green boxes that you probably see engineers working in. And then from the distribution end, which is your house end, you may have a serving telephone line that comes off a pole or UG fed. That what pair of wire goes all the way back to the same green primary connection box. The two pair of wire meet together and they're connected together. That gives you the continuous line all down the wire, and your telephone line with your dial tone that comes out the exchange, once connected, will go right back throughout all the cables or up the pole and goes right through to your house to where your socket is where you plug your phone in. So wire technology is a method of sending electrical signals through a conductor, such as a copper wire. It is used in various applications from simple household items like lamps and fans to complex machines like computers and robots. And then moving on to mobile phones. So mobile phones work by sending and receiving information using invisible radio waves, a technology called wireless because it's no cables. Yeah. So wireless are devices that transmit data over the air rather than over wire via electromagnetics. And then now we sort of at the fiber optic stage now. So fiber optic works by sending information code in a beam of light down a glass or a plastic pipe. So you probably all heard of superfast broadband. So that lets you do more online with multi people together. So you could have 20 people in your house all using the same wireless network to connect. So what I need you to do now in your groups is write down 3 wireless devices and write down 3 digital devices. So, what is fiber optic cable? A fiber optic cable is made up of thin strands of glass or plastic known as optical fiber. One cable can have as few as 2 strands or as many as several hundred. Each strand is less than a tenth as thick as a human hair and can carry something like 20,000 telephone calls. So can you imagine an entire fiber optic cable can easily carry several million calls at once? So how does fiber optic work? So light travels down a fiber optic cable by bouncing repeatedly off the wall. Each tiny particle of light bounces down the pipe like a bobsled going down an ice run. If light hits glass at a really shallow angle, less than 42 degrees, it reflects again as though the glass was a mirror, and this is called total internal reflection. It's one of the things that keeps light inside the pipe. To connect fiber together, it needs to be fused together. So to make a continuous length so the light can travel all the way. This process is called fiber splicing, and it's done by using a fiber splicing machine. An optical fiber cable consists of 3 basic elements. So it's got the core, the cladding, and the outer coating. So the core is usually made up of glass or plastic, and the cladding usually is made up of the same material as the core, but with a slight low index of diffraction, usually about 1% lower. And the core is the light transmission portion of the fiber. This index different causes total internal reflections to occur at the length of the fiber so that the light is transmitted down the fiber and does not escape through the side walls. And optical fiber coating is improved strength and it excellent in terms of heat resistant, cold resistant, and demonstrates a stable function over a wide temperature range. So it basically protects the fiber. So there's 2 types of optical fiber. So you have the multi-mode and the single mode. So the multi-mode, um, each optical fiber is 10 times bigger than one in a single mode cable. This means light beam can travel through the core by following a various of different paths in multi different modes. And then the single mode goes straight down the middle of the fiber, and another bounces down the fiber at a shallow angle. So you can see on the diagram, the multi-mode, you can see the light is bouncing off the walls, bouncing, loads of different lights bouncing off the walls. And then the single mode, you can see the light is just straight. It's just going through the middle, just straight. So the single mode fiber is designed for the transmission of a single ray or mode or light as a carrier, and is used for long distance signals transmissions. The core diameter is between 8 and 10.5 micrometers, and a cladding diameter of 125 micrometers. So the single mode has a small diameter core that allows only one mode of light to multiply. Because of this, the number of light reflections created as the light passes through the core decreases, so it lowers and creates the ability for the signal to travel further. Single mode fiber can go as far as 40 kilometers or more without hurting the signal, making it ideal for long reach data transmission applications and widely deploying it in carrying networks. It's suitable for long reach data transmission applications and widely deployed in carrying networks. So you've got the passive optical network. It's a system bringing optical fiber cable and signal all or more of the way from the internet service providers to the end user. So multi-mode fiber cables, such as a cable system, has a shorter reach, and it's widely deployed in enterprise data centers and local area networks. The core diameter of the multi-mode fiber are much larger than a single mode fiber. The light travels in multi-mode reflected paths, and each path results in a different travel distance. Because of the large core, it produces a higher light gathering, and the core is 50 micros or 62.5 micros. So the micromode fiber is recommended for fiber runs less than 400 meters, which is about 1,300 feet, and it's suitable for short distance communication with LED-based fiber optic equipment. It's widely deployed in enterprise like data centers, local area network, which is a collection of devices connected together in one physical location, so such as a building, office, or a home. So identifying a single or multi-mode cable. So fiber optic cables have like jacket colors, and they can be easily identified by the color. Um, so you've got the single mode, which the color is identified as yellow, and then the multi-mode color is identified as orange. So checking your learning. What are the three elements of a fiber? So, recap. Fiber optic works on the principle of total internal reflection. Light reaching the boundaries between two materials is reflected so it never leaves the first material. Fiber optic cables are used to transmit information for various of applications such as computer networking and broadcasting. For computer network, fiber optic cables provide information transferred with less noise reduction, no interference, and high bandwidth. Information can be transferred up to the time the usual distance before having to amplify the signal. Unlike traditional copper cable, there's no electromagnetic interference leading to more reliable signal quality. So to compare the traditional cable, fiber optic cable can carry much more data. So what I'd like you to do to share amongst the group is one thing that you have learned today. And then we move on to completing the quiz. So a quiz was emailed to all of you, and there is an email address attached to the quiz, but it's the same one that's on the slide there, just in case you can't locate. Please complete the quiz now and submit it to the email address provided. So hopefully we have achieved our aims and objectives. So the aims were to give you a clear understanding of what fiber optic is and how it works. The objectives: by the end of this session, you will have a good knowledge of fiber, optical cable, and the purpose of fiber optic, and be able to identify the different parts of the fiber optic cables and the difference between the single mode and the multi-mode, and to understand how fiber optic works. Any questions? Thank you for your participation. Thank you. Bye.